This is a short slideshow about advanced Python concepts. So we expect in this course that you already know how to program. And we already expect that you have read up on essential Python before doing this lecture. So in this lecture we'll introduce some of the more advanced Python concepts, the concepts that are fairly specific to Python in some way. So we're going to go through lists, sets, dictionaries, then map and filter. We're going to talk about lambda functions, about pip, about the JSON package, about list comprehensions, the star and double star operators, and then we're going to talk about decorators in the end. Lists is a pretty straightforward concept. So a list is an array, you could call, that can contain some elements. So here we make a list, we call it L, and it contains the elements 1, 2, 3. And then we print out L0, which is the first element in the list. So 0 is the first index, and then 1, and then 2, and so on. You can call functions on lists, for example, .reverse. That means you actually reverse the elements in the list. So from now on, if you print out the list, then you get the opposite ordering. You can also append to a list by using .append. And then here we have another list, we call it T, and T contains 3 small strings, A, B, and C. And then if we add L and T together, then we get another list which contains the original elements of L, and now the elements of T have been appended. So you can see here that lists can contain multiple types of variables. Another data structure is sets, and here we create a set, we call it A, then we add the element 1, we add the element 2, and then we print it out. So now it contains the elements 1 and 2. And then we add the element 1 again, but that still becomes the same set, because a set is something like a list, but you can only have each element once. Then we create another set, we call it B, and that set will contain the elements 2 and 3. So you can see here we instantiate the set B from a list. And then we print the union of A and B, which is, you get that by saying A.union of B. And that takes the elements in A and the elements in B together, which is 1, 2, and 3. And then we print the intersection of A and B, which is the elements that are both in A and in B. And that's a set as well, containing the element 2. The next data structure is a dictionary, and this is a data structure that you're going to use a lot in computational tools for big data and in Python in general. So here we create first an empty dictionary, call it D, and you do that by using these brackets. And a dictionary is kind of a key value store. So for each key in the dictionary, you can store a value. So here we say that D name equals David, which means that at the key name, we'll store the value David. And at the key age, we'll store the value 26. And then we can print out the dictionary. So now you can see that the age is 26 and the name is David. Actually, I'm 27, but I haven't changed these slides since last year. You can also print out a specific value at a specific key. You can do that by saying print D and then putting in the key in square brackets. Then you can work with the values that are stored in the dictionary like you normally would. You can say dh plus equals 1, and then you get my actual age. And then here we create another dictionary, we call it F. We have a name called Peter, we have a nationality called Danish. And then we ask, is the key H in F? And it says false, because in F there is no key called H. So dictionaries is something you use a lot for storing data, and it corresponds a lot to JSON, which we'll talk a little bit more about later. Lambda functions is a way to define small functions inline. So you know you can do functions that are, like generally functions is a concept you use a lot in programming languages, but often you just want to have a very simple function. So here we make a small function, we call it f, and we make f a lambda function. And you can see here it says f equals lambda x colon x plus 2. This means that f becomes a function that when taking in x as input, it outputs x plus 2. Now we can use it, we can say f of 2, and then we get out 4 as expected. Now we define a normal Python function, we call it do twice, and do twice will take two arguments, an argument f and an argument x. And here f is assumed to be a function. And then it returns the function f of x. So it applies the function f to x twice. And then we print out do twice, and then as the function parameter, we input a lambda function, which takes x as input and then squares it. So it becomes x squared. No, that's not true. It takes x as input and then outputs x times 2. So it multiplies by 2. And then it takes in the number 1. So here we say take the number 1 and apply the function x becomes 2x. Do that twice. So 1 becomes 2 and 2 becomes 4. So this is a little bit convoluted, and lambda functions are very neat and very nice, but sometimes if you use them too much, the code can become a little bit hard to read. Finally, we make a new lambda function, we call it g, and g takes in two parameters, x and y, and it outputs x plus y. And now we can see that g of 1, 2 gives 3 as we expected. Another concept in Python is the map and the filter functions. And here we're going to use the lambda functions again. So first we create a list, we call it A, and it contains the numbers 1 to 5. And then we say, okay, what if we want to get a new list, but where we get the same elements as A just multiplied by 2? Then you can use the map function. So map takes two arguments, it takes a function and it takes a list. And then it applies the function to every element of the list. So here we give it list A, which is the one we just defined, and then we give it a function that multiplies the input by 2 to get the output. And then we say apply this lambda function to each element of A, which gives us the list containing the double of each element of A. The next thing we can do is what's called a filter function, and filter also takes a function and it takes a list. And then it uses the function on each element to determine if it should keep it or not. So here the lambda function we're passing into filter is a function that takes an element x, or a value x, and then it checks if x modulo 2 is 0. So that means is the number even or odd. And if it's even, the lambda function returns true, and if it's odd, it returns false. And then we say filter the list A with this lambda function, and out we get the even elements of the list A. So this is a way to filter your lists in a very easy and neat way. The next concept is called list comprehensions. List comprehensions are rarely a necessary construction, but they're usually a way to write something in a very neat and short way, and confusing sometimes. So here we make a list, we call it A, contains 1 to 5, and then we make a new list. And that list is defined as x to the power of 2 for each x in A. So basically we say make a new list where for each element x in A, you should have x to the power of 2. So that's 1 power of 2 is 1, 2 to the power of 2 is 4, and so on. So this is a very quick way to get a list based on another list. We can also say, give us a list where we take x to the power of 1/2 for each x in range 5. So here range 5 is a function that gives us the numbers 0 to 4. And then for each of those, we take x to the power of 1/2, which is the same as the square root. So this gives us the square root of 0, 1, 2, 3, and 4. Another thing which is not a Python library in the same way, but is a program you can use to install Python libraries is called pip. And the way pip works is that you say pip install, and then you take a package name. And you can also upgrade the packages you have. So let's say you want to use the package JSON, which we're going to talk about in the next slide. Then you can say pip install JSON, and then pip will install the package and everything, all dependencies, and then set everything up for you. And you can get pip for Windows, Mac, and Linux, so there should be no problems. And pip is just a really, really neat tool, so you need to get a hold of that. Then there is a package called the JSON package, and JSON is a format for storing data, which Python uses a lot. So here we start by importing the JSON package or the JSON module, and then we create a dictionary. We call it D. It contains the name David and a variable or a key nums, which is indicating numbers, and then we have a small list containing the elements 1, 2, 3. And then let's say you want to save this dictionary in a notepad file, for example. Then what you can do is you can say json.dumps, which means dump string, and then pass in a dictionary. Then the JSON module will convert your Python object, in this case the dictionary D, into a string that it can save. So now you get out a string, as you can see here, that looks a lot like the dictionary. Then you can say f equals json.loads, which does the opposite. So it takes a string that is a JSON string, and then it creates the Python object from it. So now we pass in the string we just had from before, and then f actually becomes a functioning dictionary. So we can pull out the nums key from the dictionary. So this is a way to convert Python objects to strings and then to convert the strings back to Python objects. So this you can use if you want to save, for example, the contents of a dictionary to a file on your computer and then load them in later. The next concept is a little bit complicated to understand. It's called a star operator. And the way the star operator works is that you can kind of look at it as a way to unpack a list. So if you start by looking at the second line here, it says my sum of 1, 2, 3 equals, and the output of that is 6. So you can see that my sum is a function that takes in some numbers and outputs their sum. If you then look at the way we define my sum, we say that we create a function, def, we call it my sum, and the input to my sum is a star and then args. So this is a way to say that there's going to be a number of arguments here, like you see 1, 2, 3, and we don't know how many, but when you get them in, just look at them as a list. So in the function mySum, the args variable is a list of the arguments passed into the function. Then we make a variable called r, and then we loop over the elements in args, and we sum up the elements to the sum r, and then we return r. So now we have a kind of a neat function, mySum, which takes a variable number of arguments. You can pass in 1 argument, 2 arguments, 3 arguments, and so on, and then it sums them up. And now we're going to talk about the star operator again. So there's multiple ways to use it. So first of all, you can see I use it here in the definition of mySum. And then I use it in the end here to say, what if you have a list A containing the numbers 1, 2, 3, and you want to pass in that list to mySum. So mySum assumes a number of elements coming in, not a list of elements. So you can use the star operator here to unpack the elements of A. So the list of 1, 2, 3 becomes 1, 2, 3. So you can kind of look at star as a way to unpack lists into the individual elements. So the next argument here, or the next operator here, is the double star operator. And the double star operator works like the single star operator, but instead of working on lists, it works on dictionaries. So here I create a dictionary called B. It contains name David, age 25. So I keep changing the age. And then I make a fairly complicated function. I call it dicttypes. And what dicttypes does is that it looks at the keys in the dictionary that it receives, and then it prints out the name of the key and then the type of the value at that key. So if you see the next line, I use it on my dictionary B, and it says there is an age key containing an integer and a name key containing a string. So if you look at the final input here, I say dicttypes, and then the input is var1 equals test as a string, var2 equals a list 1, 2, 3. So like before, we could put out, you can see, I'll go back a slide. So here we could say that mySum either takes the elements 1, 2, 3 and sums them up, or you can pass in a list, but then you have to unpack it first. So this is basically the same. Either we can put in key value arguments as we do in the last line here, or we can put in a dictionary, but then we have to unpack it. So you can look at double star as unpacking a dictionary into key value arguments. The final concept I'm going to talk about is decorators. And decorators is something that is pretty cool for Python. It's not something you're going to need to use in any of the exercises in this course. So if you find it totally confusing, don't worry. So a decorator is a function that you can put on top of other functions in some way. So here I'm going to make a decorator function. It's called off by one. And the input to off by one is another function which I call original function. And inside here, inside off by one, I define a new function which I call new function, which takes two input arguments x and y, and then it returns the output of original function with x and y as input, and then it adds 1. And then off by one returns a function, it returns the new function. This is a totally complicated function. It takes a function, defines another function that depends on the input function, and then returns this new function. So what I can do now is I can say, okay, I want to make a new function, I'll call it add. And add takes x and y, and then it returns their sum. So add is a pretty simple function. But what I can do then is I can say, every time I want to run the add function, I want it to be off by 1. So what I do is that I put this add symbol off by 1 just above the definition of the add function. And this means that from now on, when I run my add function, it's just going to be off by 1 because it's going to start by running the decorator function off by 1, which takes the add function, makes a new function that runs add and then adds 1, and then outputs that function back. So this is totally convoluted. But the idea is that you can make these kind of decorator functions that decorate your normal functions to make them behave a little bit differently. So an example of this in a much more complicated setting where it makes maybe more sense to use it is that if you write a web service and you need to run some different functions sometimes where you compute some stuff, but to run some of these functions you need to be an administrator, you need to be logged in as an admin. And you don't want to do an admin check or a login check in each of your functions. Then you do a new function which you call isAdmin, for example, or requires admin. And that function just does the admin check once. And then you decorate all the functions where you need to be an admin by that function. So you can make a decorator called isAdmin that you can use just before all the functions where you need to be an admin. The last slide of this presentation is about Anaconda. So you're going to be installing a lot of different packages in this course, and many of those packages are contained in this thing called Anaconda. So it's a Python distribution, so it kind of replaces your normal Python distribution. But then it contains all these packages that you're going to need. It's free, it's cross-platform, and it's for many people much easier than installing all the packages yourself. So this is something you can use if you want to.